In this lesson, we are now focusing on the relationship between our exponential and logs, and that inverse relation still, but how to rewrite them. So basically here, using this image, when writing, we are going to convert. So like here, the base is always going to be the base. So notice how the base of our exponential is the base of the log here. Now, notice the exponent is what the equation is equal to. So then notice how our value of what our exponential is equal to is here for our log. So like this is log base b of a is equal to x. So again, our base is the base and our exponent is what the equation is equal to. So like here, for example, in 1a, notice the base of our exponential is 3. So I'm going to write my base 3. Then what is the exponent? 5. So that means our equation is always the exponent, which is 5. So this is our exponent. So that means here we have log base 3 of what? 243 is equal to 5. So again, the base is the base, and your equation is equal to the exponent. So again here, what is the base? 25. So log base 25, then what is our exponent? What's the equation equal to? 1/2. So here we've got log base 25 of 5 is equal to 1/2. Go ahead and pause the video and try you try on your own. And here we go. So here, log base 6, then your exponent was -1. So log base 6 of 1/6 is equal to -1. So again, here going the other direction, right? The base is the base. Your equation is equal to the exponent, or the exponent is the equation, what the equation is equal to. So again, here the base is 9. So 9 to the what power? To the first power. Because remember, right, the equation is equal to the exponent. And if you think about it, right, what is 9 to the first power? Well, 9 to the first power is 9, this value here. So 9 to the first power is equal to 9. So same thing here. What is our base of our log? 5. So 5 to the what power? 0. Now, anything to the 0 power, guys, heads up, if you did not know this, is always equal to 1. So 5 to the 0 is 1, which matches. Log base 5 of 1 is equal to 0. So go ahead and pause the video and try on your own. And here we go. So here your base was 64, so 64. Now raise that to the exponent of 1/3. 64 to the 1/3 is equal to 4. Now keep in mind, how do we know this? Well, 1/3, if you recall, is the same as the cubed root. So cubed root of 64 is 4. So it matches. And so here, just again, practicing our rewriting, but using variable. So like here, for example, I've got my exponential. So we're going to write this as a log. So here we go. What is the base? A. So log base A, then what is our equation equal to? Well, what is our exponent? B. So log base A of C is equal to B. That is our equation here. So now here we have our log. We're going to write this as an exponential. So again, what is the base? M. So this is M to the what power? N. So M to the N is equal to what? P. So go ahead and pause the video now and try this on your own. Notice how you have an exponential, so that means you are converting it as a log. And here we go. So what is the base? This is log base r of t is equal to your exponent, which was s. So notice here, right, make sure to separate. Now, for those who try these double-starred questions, go ahead and pause the video and then try these, and then I'll go over this with you. And here we go. So here you are rewriting this log as an exponential. The extra step, though, why this is a double start is you're solving for v. So first, rewrite it as an exponential. So here we go. What is the base? 0.8. So 0.8 raised to the what power? T. 0.8 to the t is equal to v divided by 17,000. Now, just from this right here, I should have 0.8 to the t. So see how this is just 0.8? So I'm going to cross out c. See how this is just 0.8? So I'm going to cross out d because I need 0.8 to the t. Now it's like we're solving an equation for v. Notice how v, though, is being divided by 17,000. So we need to solve by doing the inverse or opposite operation, right? So what is the opposite of division? Multiplication. We're going to multiply both sides by 17,000. That's why the answer here is B. So then the second one, same thing, right? We are rewriting as a log and we're going to solve for t. However, thinking about this like we had our exponentials and our radicals, or our quadratics and our radicals, we always had to get this value here by itself. See how our base and our exponent being multiplied by a? So we have to get rid of this. So what is the opposite of multiplication? Division. So we are going to divide both sides by a. Now I've got my exponential. 5 to the t is equal to c divided by a. Now we can write this as a log. So this is log, what is the base? 5. So log base 5 of c divided by a is equal to t. That's why the answer here was C. So now here we're going to be solving just some basic equations and we're just going to focus on logs. So with this here, so notice with this first type of problem here, we're solving for x. Now see how we've got log base 2 of 12. So here, if I were to convert this, it's like we're looking for the exponent. Now, another way of solving for the exponent is we're going to use what's called the change of base. So again, see how we have these two values here together? We can't just put that in the calculator like this. We can't just put a log and then a base 2 because our calculators actually only calculate in base 10. So what we do is we're going to use what's called the change of base. Put this in the calculator where we divide two log values here. Now, the key is this. The base goes in the bottom. So log of 2. That means here up top, we have log 512. And that is what you put in the calculator. Log, you press the log button on your calculator. So log 512 divided by log of 2. And if you need to, make sure to close the parentheses here because they open. So log 512 divided by log 2, you should get 9. So same thing here. We cannot just put this in the calculator as is, this base 49 here. So see how we have our two values here together? So that means we're going to do change of base. So this is log being divided. And again, the base goes in the bottom. So what's the base, 7 or 49? The 49. So notice how log 49, and we have log 7 up top. So again, practicing putting this in the calculator, you get log 7 divided by log 49, which gives you, you should get 0.5, but make sure to also practice converting that to a fraction, so you get 1/2. Go ahead and pause the video now and try the U-try on your own. And here we go. So again, you should see here, we've got our values. So we're going to change the base here, change a base formula. You should have put what in the denominator? 5, because that is your base. So you should have divided log of 625 divided by log of 5, and that gives you 4. So now here, notice it's different because this is not log base 8 of 1/3. This is log base 8 of x. So see how here, that means now we can't use change of base. So we're going now to convert. So we've got our base, which is 8. 8 raised to the what power? 1/3. 8 to the 1/3 is equal to x. So again, if you want to practice putting that in the calculator, remember, right, you have 8, then you press that caret button, then 1/3. And if you have a fraction, you can keep it together as your in parentheses. So 8 to the 1/3 or cubed root of 8, and you get the value of 2. So again, notice now here, we're not going to use change of base. We're going to actually convert. So like for the next one here, can we use change of base? No. So we do need to convert, right? So what is our base? The base is 5. So I've got 5 to the what power? 4th power. 5 to the 4th power is equal to a. So 5 to the 4th power, just put that in the calculator, right? Pressing that caret button, and you get 625. Go ahead and pause the video now and try this U-try on your own. And here we go. So you can't use the change of base, right? So base 3, raise that to the 4th power is equal to x. 3 to the 4th power is 81. Now, these last examples here are a little bit different because see how the log is just by itself? It's understood that here we have our common log, and this common log will always have base 10. So common logs, the log here is base 10. So now we can solve for x because this has a base of 10. So this is 10 to the what power? 10 to the 5th power is equal to x. So that means 10 to the 5th power is 100,000. So again, see how the log here is by itself? Log base 10. So this is 10 to the 3rd power is equal to x. So 10 to the 3rd power is 1,000. Go ahead and pause the video. Try this U-try on your own. And here we go. So again, this log is by itself. So this is log base 10. So 10 to the 7th power is equal to x. So here you end up with, you should have gotten 10 million. And so now here for our last example, this is the natural log, ln, which is inverse or base is e. So here, to rewrite this, this is e to the 2nd power is equal to x. So natural log is different from common log. So this log here has a base 10 versus our ln, our natural log is e. Then if you recall, e is that irrational number that we use like in our PERC formula. So make sure, if you notice, it's right above that ln button on your calculator. So now you just have e, find that, to second shift, e to the 2nd power, which is approximately 7.4. So again, same thing here, right? This is natural log, ln. So we write this with e. So this is e to the 3rd power. E to the 3rd power is approximately 20.1. So here, pause the video if you need to. And again, with our natural log, so e, so this is e to the 5th power, which is approximately 148.4.